action by A on B causes an equal and opposite reaction, an equal and opposite reaction, and opposite reaction, equal and opposite reaction by B on A. That's what we can write there. Right, then we are on to part B. We are going to use the conservation of momentum to show that, or rather, we are going to use the conservation of momentum to show that the ratio of mass Y over mass X is 4. How do we do that? Well, the principle of conservation of momentum says that for an isolated system of interacting bodies, the total momentum in any given direction is constant. This means that momentum before collision is equal to momentum after collision, provided that the system is isolated. There are no external forces acting on the system. Right, so what is the momentum before collision? Before collision, we have mass X times 5v. After collision, however, we have the two masses stuck together and moving at a common velocity of v. Right, since we have v on both sides of the equation, the v's can cancel out and we'll be left with 5 mx equals mx plus my. Right, now if we take mx to the other side, it will be subtracted and we will have 4mx equals my. 4mx equals my, and this will give us the ratio my over mx. There you have it. And so we're going to calculate this ratio. The total kinetic energy of x and y before the collision is only the kinetic energy of x, because only x was moving. So kinetic energy is half mv squared. Right, so before the collision we had only x moving, so it's half mx times the speed of mx before the collision squared. This gives us 25 over 2 mx v squared. After collision, we have both x and y moving at a common velocity, so kinetic energy was half. Then the masses were combined. The masses were combined, and the velocity was just v, like that. This is after collision, and before collision we have this. The v squared can cancel out, then this and that will cancel out, and we will have 1 over 25 right there. Then we have to remember that my is 4 times mx. So up there, this thing here is equivalent to 5 mx. So we have 5 mx over mx. So the ratio will simplify to give us 5 mx all over 25 mx, and this simplifies to give us 0.2. That's the ratio there, 0.2. Then item 3 says state the value of the ratio in 2 for a perfectly elastic collision. Well, for a perfectly elastic collision, total kinetic energy before and after impact is the same. So the ratio is just 1. Right, then we have this, the variation with time t of momentum of block X is given right there. Right, what are we supposed to do? Block X makes contact with block Y at time t is 20 milliseconds. Describe qualitatively the magnitude and direction of the resultant force, if any, acting on block X in the time interval. Right. Now, the resultant force acting on block X is constant for the first, or rather, is 0 for the first 20 milliseconds. Why? Because there is no change in momentum, which means there is no change in velocity, which means acceleration is 0, which means the resultant force is 0. So for the first 20 seconds, we can write resultant force is 0. Resultant force equals 0. Or we can say no resultant force. Right, then for the other part, constant resultant force in the opposite direction. In the opposite direction. Constant resultant force in the opposite direction. Right, then for this part that says sketch the variation of the momentum of block Y with time t from 0 to 60 milliseconds. All we need to do is, firstly, Y was not moving, so its momentum was 0. Right, so in the first 20 seconds, the momentum of Y is 0. In the first 20 seconds, the momentum of Y is 0. That line there is supposed to be on the 0 mark. 0 right there. Then it changes, it increases as Y experiences a force from X. So it increases at a constant rate. Right. Then it becomes constant at that point.